Hello everybody, welcome to this month's stream. So we'll get started in just a second. Just for now, just let me know if you can hear me here in the live chat. So if you hear the audio okay, just give me a little heads up in the live chat. All right, awesome. All right, guys, let's get started. So let me just switch my screen here. Okay, so in this webinar, what I wanted to do was take a look at some various rendering workflows for Substance. So one of the areas that we're starting to focus on, as we move into other markets. So for instance, we're working in games. We're also moving towards design fields, ArcViz, and things like that, and then also VFX. And so we get a lot of feedback from different studios and such about, different renderers and how we work with that. And we're going to continue to evolve this in many ways. So what I'm going to show today is kind of where we are right now in terms of being able to work with substance materials inside of third-party renderers. And we're going to take a look at specifically like Arnold and Vray, some of the top two renderers that we get the most requests about. Also, we're going to take a look at how we can use Substance Painter files as well. So with that said, another thing that we've done is, and actually let me just post the link here in the chat. So I started working on a whole new documentation space for rendering. And so here, just bear with me for a second. I'm just going to grab this link here. So in our integrations, we now have a new rendering section. And so this is going to be like a new repository that we're going to have for all kinds of rendering. Right now, we're looking at we have documentation for Arnold, Vray, and Corona. So let me post this here into the chat window. Here we go. So we're gonna, like I said, we're gonna keep evolving this documentation. So it's also going to, start to move into covering, even more renderers. We're looking at like Octane, Redshift, and so on. As well as being able to talk more about MDL. Then also, we're going to start to work on the substance integrations themselves, and we're going to add a new functionality where instead of having to do any type of conversions or anything like that, you can, the substance engine is going to take care of these conversions. Say, for instance, you want to have a substance that uses metal rough and it goes straight to V-Ray, you just choose the V-Ray option, and all of the conversion is going to happen behind the scenes for you. So, like I said, we're really going to start to push support for rendering. Now, with that said, if we take a look at Substance Source, so here, let me do this real quick. Let me just break off a tab here. Let's see, move to new window. All right, let me bring this into view. So here's just a browser tab. And here's what we have with Substance Source. So all of the substances that we have with Source, the way that we are supporting Substance, and we've always been doing this, but we're not going to change this. So for example, with a substance, if you download, let's say that I come over here to like maybe one of these metals, and I look at, let's just say, I don't know, this guy here, steel panel roof. When you look at this substance, you're always going to get the same level of outputs, meaning that it's either going to be metallic roughness or it's going to be specular glossiness. Right now, we're only showing the metallic roughness, but when you get the substance, it contains both. So it's going to be metallic roughness or spec gloss workflows, and those are going to be the two types of outputs that we always support. So for example, we're not going to start saying, oh, okay, well, we're going to have, metal rough, spec gloss, and now we need to have specific outputs for V-Ray, for Arnold, for Corona, and all these renders and so on. We're not going to get into the business of trying to do all that type of support in a single substance file. So it's always going to be these two main formats. But with that said, there needs to be information on how you use these formats in specific renders. And like I said, we are going to have some new functionality within the Substance plugins that do conversions. And we'll talk about these conversions when we take a look at V-Ray. but it's going to do all that for you automatically. We get a lot of questions about this because more and more studios are starting to use Source, and they want to know information like, well, wait a minute, how do I, if I've got Metal Rough and Spec Gloss, how do I use this with V-Ray and so on. So like I said, that's going to be kind of the topic of what we're going to cover here today. All right, so let's just jump into this, and here you see that I have just my Maya scene, and we're first going to take a look at the Arnold renderer. Now, what I'm using is the updated Arnold 5 renderer, and which is really nice because Arnold 5 now just completely, they've changed their Arnold surface shader, and it just supports metallic roughness. So as you'll see, I just have a simple cube here. Let me just run my IPR here, and I'll just bring this over into view. Here we go. And so here you can see that, we're rendering this substance. This is a substance that I just grabbed right off Substance Source. And so here I'm just rendering it with Arnold 5, and we're just specifically using these metallic roughness outputs here directly into this. So what I want to show right now is how we can actually set this up. And we're going to do it step by step, and then we'll take a look at the variation for using Substance Painter files as well. So first, let's take a look at some of the steps with the Substance plugin as it works now, or as it stands now. So one of the first things I have here, you'll notice that I just have a panorama HDR image here. And so for the light, it looks like my shelf lighting here is gone. So what I'm just using here is just the Arnold Sky dome light, and then I just attached to this the panorama map HDR that just ships with Designer. So this also ships with Painter as well. But you can get access to all these HDRs just in the program files, and I'm just simply using this here. So that's just my environment. No other lights, just full environment. Okay, so now let's take a look at what I would do if I wanted to use this substance here. So the first thing I'm going to do is just come into here and create a new substance texture. So we'll just create an output of this. Now, the substance itself, we are constantly updating the plugins. And if you go to our algorithmic.com downloads page, you'll now see that we have updated plugins for 3ds Max and for Maya. So if you want to use the version that I'm using here, you would just go to that page, download, just hit the download button. That's going to give you 2017. And then right underneath kind of the description of Maya, you'll see a little small link that lets you have access to previous versions as well. So, and I say that because the version of the plugin that ships with Maya is super, super old. It's like 2012, and it doesn't support any of these features. So you do need to update that in case you haven't already. Okay, so here is the Substance plugin. And I want to use this for an offline renderer. And like in this case, we're going to show Arnold, and then later we'll show Vray. So what I'm going to do right now is just take my workflow, and I'm going to switch it over here to custom. Now we have PBR, and what this is doing is just, it's a mode that's just going to hook the outputs to the Stingray shader so that we can just use the Stingray shader, which is a PBR shader for real time, and so that we can just view the results here in our 3D view. But if we were to render that, we'd have to use it with the hardware renderer, and it's limited and so on, and that's not what we want to do. So I'm going to set this here to custom. And like I said, this workflow is going to change in the future because what we'll have is in the dropdown, you'll actually see Arnold and you'll actually see Vray and things like that. So for now, what you would do is you would choose custom. Now, a next step to this is I want to come over here to this automatic baking section. And we have this option here called automatic connections. And what this does, and we're actually going to rename this so it makes a little bit more sense. And basically, we're going to rename it to cache substance output to disk, because that's essentially what we're doing. When you create a substance, it gives you a substance texture output. And I'll show you what that is. And it technically is a texture that lives in like video memory. It's not actually like a texture that's sitting on disk somewhere. And third-party renderers, like you'll have like Arnold or say Vray, they don't work with that VRAM texture. So we have to have a baked version. And so that's what this option is doing. And then we have a format, which we could change if we want to. I just leave it at PNG. Okay, so here we have that set, and we set our workflow to custom. Now, of course, I need to load the substance file. So I'll just go and browse for this guy here. And this window is kind of showing up on my other monitor. So it's all right. Let me just find this guy here real quick. So here I'm just, browsing for the file. And let's see. Got it in a special location here, substances. Okay, let's do this one. All right, so we'll click open. All right, so I've opened it, and here we have like a drop down for graph. Now, if you choose a substance that has multiple graphs, you can select which graph you want to actually work with. So here in our case, you'll notice that, like I said earlier, the substance, and again, this is a substance right from source, it's going to support both spec gloss and metallic roughness. So with that, you'll see we have a diffuse texture for spec gloss, and we have a base color for metal rough. Now, since we're using Arnold 5, I'm just going to use this. I'm just going to use metal rough directly. So here, let's do this again here. Well, let's go this way here. Let's do create a node, and let me bring my create node window over here into view. And you'll see I've got it several renders here. We want to look at Arnold shader surface. And so the one we're going to work with here is just the Arnold standard surface. So I'm just going to select this to create the standard surface shader. And you'll notice here that we now have base color. Here you'll notice that we have metallic and roughness is in here. We'll set it up as we go, so we won't have to look at it that way. So let's just move this guy out of the way for now. Okay, so going back to the substance, we need to create the output. So now I can just come over here to this output section, and I'll just click the button to create an output. And so my graph just kind of rearranges for me the way I have it set up. So let me just kind of zoom in, and I wanted to show you specifically what's happening here. Okay, so this is our substance node that we had. This node right here is what I was telling you. This is the substance texture, and you can see it's actually rendering a texture. And this is the substance texture that lives like in video memory. And so we can't actually connect this guy here. We couldn't do its out color and connect it right into Arnold. So we need to have like a baked version that goes out to disk. So you'll notice because I had automatic connections enabled, it's generating this node for me, which is an actual texture. So if you notice, what it is just the same file texture 2D node from Maya, and it's looking for a file that's been written here to this local temp directory. Now, another thing that we're doing to support some studio workflows, like a recent trip I went to the mill where they were using this plugin, we want to be able to set a user preference for where these baked textures are going. So right now, like I said, just throws it into a temp directory. But an update to the plugin, we're going to have it to where you can set a user-defined directory for this. And that's going to be very useful for things like network rendering and so on. All right, so like I said, we have just our standard Maya 2D texture node, and which is we have all the features that we would use. We have like our color balance and everything. And we also have our color space, which is very important. And as you'll see, we're going to actually use this. So since this is base color, I want this just to be this sRGB. All right, so let's come over into here. Let me just middle mouse, click and drag this new Arnold's standard shader here onto my object here in my scene so we can start to work with this guy. And so now what I can do, here under my base, we're just gonna middle mouse, click and drag the texture and just place it right here onto color. And so here we go. You can see that it's working simple enough. So now you'll notice that we also have this metalness here. So let's start to work with that. So the next thing I'm going to do is we'll just come back here to our substance, and let's just enable here our metallic. So we'll get this guy. And again, I've got to kind of just rearrange my graph. So this is our metal. And I try to rearrange these guys so it just visually, makes sense when I'm working here. So we'll just kind of do this. Okay, so now you'll notice that, like I said, we have this metal. In this particular case, this is a pure metal, so it's full white. And we have our substance texture here. That's the baked version of that. Now, because this is, representing actual data, we need to make sure that we change our color space here from sRGB to raw. So I'll just scroll up, and we have the setting here for raw. And that's basically going to set this to linear. And so that's what we need to do for the color space. So kind of the rule of thumb for this that I follow is any image that you have. So say, for instance, we have this texture here, which is our base color that we can see that's just rendering here on our mesh. Anytime you have something like color that represents diffuse reflected color, and that's going to be like the color that we see, like sometimes I say like the red skin of an apple, or the brown color of wood or something like that. It's that diffuse reflected color. We want that to be sRGB. And if it's a grayscale map that represents data like metallic or roughness or something like, or ambient occlusion or something, then those are going to always be set to linear. So just that's kind of like a basic rule of thumb that you can follow. Okay, so let me just select this metal. Now there's one other thing that I'm going to do with this guy. Now you'll notice here that I've been using this method of just middle click and drag and drop and placing these on here. Now one little caveat with that. So if I wanted to like manually hook this up, I could do it. But if I just manually drag and drop, it'll kind of set things up a little wrong. So what I need to do for any of my grayscale textures, I need to come over here to color balance. And if I scroll down, there's an option here for alpha is luminance. I just need to make sure that's enabled. So we'll just enable it. And like I'm kind of showing this step by step right now because the way we have it, it's a bit manual. And you know, again, we've got work to do on this. I've already placed tickets in our system to make sure that we just all this is going to be done automatically. You know, so but in a way, it's kind of good. Teaching wise, if you think of it that way, because it lets you know an understanding of why we are doing this, you know. And so I find that, you know, when I'm teaching this, and this might be a good thing for you guys when you're teaching students, is, you know, you're saying, hey, we're manually setting this up, and the reason being is because here you can, you know, discuss the whole principles of linear space rendering, you know, like, oh, well, this is representing diffuse reflected color we see. It needs to be sRGB because we're authoring these textures in a gamma space, but we're rendering in a linear space, so we need to just make sure we flag these images appropriately. I get a lot of questions about this kind of thing, and there was one in particular today where someone was asking me like, oh, well, you know, I'm kind of confused on this linear rendering stuff. Does it mean that, you know, I need to always enter my values in as a linear value and all that kind of stuff? And the answer to that is no, you don't want to work that way because, you know, we're not seeing things that way. Our monitors are not displaying colors to us that way. We're always in sRGB space. So we want to work that way. And the whole thing is we can work that way. And so we can visually see, oh, when I pick a value, this is what it, you know, this is what I want it to represent. But the whole key and the whole thing that makes this work is just how these outputs are getting flagged for the renderer to know what to do with them. So in this case, it's flagged as sRGB, so internally the renderer knows, oh, I need to linearize this. I'm going to apply an inverse gamma and remove the gamma encoded value from this sRGB image. You know, so we don't have to manually, you know, do that. We can just tell Maya to set it to sRGB, and it does it because I have color management enabled. And that's an important thing that I forgot to mention to start. I always forget where the preference is. It's in here somewhere. Let's see here. Is it under... I think it's window, settings, preferences, and let's drag the window over here, and color management. There we go. So you just want to make sure, for everything I'm doing here with setting these, you just want to make sure enable color management is turned on. I think it is by default, but just make sure that you have that enabled. Okay, so like I said, we're doing it manual, but this could be like a good way to kind of help explain what we're doing here. So again, this guy, it was authored in an sRGB space, but we need to tell the render, hey, I want you to view this data as actual linear values. It represents data, not, you know, actual color that needs to be gamma corrected. And like I said, so I can use my little middle mouse click and drag. I make sure that I enable alpha as luminance. Okay, so now I can just simply middle mouse click and drag and place this here on metalness. So we'll get this working. Let's see here. Another thing I just want to double check for what I'm doing here. Okay, so one other thing that can be a little confusing with this guy is these weight values. So you'll notice here that you have a weight value, and the weight value is basically just like a weight of the color map that's used. So here in my diffuse, I want to just, you know, pull this all the way up. Here for my weight on my specular here, I want to make sure this guy's all the way up here, and so on. So the next thing I'm going to add to this guy is going to be my roughness. And here, let me just double check and make sure that's all I did on this one here. Yeah, so I just had my roughness here with this guy. All right, so let's do this. We'll come back into here, and we'll go back to our substance, and let's just enable our roughness here. So here we go, and again, I'm just going to move these guys just so they're kind of underneath of each other. So again, this is our roughness. This, you can see the map here. This is the baked texture version of that map. It's going to represent data, so we're going to switch this to the raw mode. So just move up, whoops, here we go, set it to raw, alpha is luminance, and here we'll come back to our material, middle mouse, click and drag this here onto our roughness. All right, so now we're starting to get, you know, some information here, as you can see. Now again, I want my weight set all the way up. And in this case, the color value is just set to white. We're not really working with this per se because, like I said, we're using the metallic roughness workflow in this case. Let's see. Another thing about this workflow is you'll notice that, you know, I'm not worrying about, or I'm not adding like ambient occlusion or anything like that, because that's all going to be handled within the rendering system, because this is going to be a ray trace rendering system, and we're not using like ambient occlusion like you would in a real-time shader where it's just something that we're adding as part of the shader. We can actually ray trace render it with ambient occlusion, so we don't have to really worry about that. So the next thing we want to do here on our material, now that we have all this set up, we're going to scroll down to where we have, let's see here, our geometry, and you'll have our bump mapping here. So what I can do here, and actually let's do it this way. Let me just click my button here, and it's going to create a render node to this guy. And a couple different ways to look at this. What I want to do is just kind of check to see, which I don't think we have to worry about that here with Arnold. Like, we don't need to use like a very specific like bump node like you can with Vray. So here, let's do it this other way then. All right, let's go back up to our substance real quick, and let's just enable our normal map, because we're going to use our normal here. So here's our normal channel. We'll just click, and it's going to generate the map for me. Here they are. So just as I've been doing, let's just kind of organize this a bit. We'll just drag this guy down into here. And here's our texture. Once again, this normal represents data. So in order to get this to render correctly, we are going to make sure that we set this here to raw. We don't have to worry about alpha as luminance because this is a color image. We only have to worry about that with grayscale textures. All right, so now we'll come into here and we'll drag this normal right here into our bump mapping. And you'll see what this does for us automatically is it creates a bump 2D node, so we didn't have to worry about that. So we'll come over to our bump 2D node, then we're going to make sure we have use as tangent space normal, and that's going to set up our normal here. And that's pretty much it. So now we've got everything set up. Let me save this in case we get some spectacular crash, which usually tends to happen when I'm doing this stream. So let's get this going, and we'll render here our IP. We'll do our IPR render, and so here we are. You can see this is the render that we get so far. Now here we've got one other thing that's happening here. It looks like my normals, my normal map's inverted. So let me take a look at that. If I remember correctly, on your bump 2D node, there is an Arnold attribute for this. Now, you'll notice that this attribute has flip the green channel enabled automatically, so we want to uncheck that. So now we'll come back here to IPR, and we'll do our render again. And so now our render, you can see our normals are correctly inverted. Well, not inverted, but they're, you know, it's now flipped, so now it's rendering correctly. So what you saw before was the green channel was flipped. So you need to set that as part of the, like I said, you need to set that as part of that bump 2D on that Arnold attribute. Now, another thing that can be a little confusing about that, in case you have students run into this, is if they come over here to their substance node, on all the substance nodes, there will be a basic parameter, let's see, here under normal format OpenGL. And so because the Arnold attribute is flipping this, even changing this, it would just kind of mess things up. So that's why you're going to leave it at OpenGL, which is going to be set correctly for Maya, and then you want to make sure that you flip it, you know, just turn off the flips. Or I guess technically you could come in here and switch it this way, and it would fix it as well. But I just tend to kind of turn it off in that bump 2D node. Okay, so that's as simple as it is for working with Arnold 5 now. So it's much simplified. In like previous versions of Arnold, you did have to do some conversion stuff like what we're going to show with Vray. Okay, so while we have this set up, let me just save this guy, and then let me just open up another scene here. So we'll open a scene, and let's do Painter. So I'm just going to open this up, and as you'll see, this is going to be pretty much the same thing. So let me just get this guy loaded up. And turn on my textures here. There we go. All right. So as you can see, this is just like kind of that sample test screen, and that we use inside of Painter. So it's just the open sample scene, and so I'm just using this guy to do the actual the tests or whatever for everything. So here, what I did was I just exported, in the case of Substance Painter now with Arnold 5, I just used directly the document channel. So inside of Painter, I was using metallic roughness, just exported the document channels, and then so here we have the maps, and as you can see, color is sRGB. You've got my metallic is going to be set to raw, and my color balance, alpha is luminance. Same thing for roughness, and here for my normal. So then those guys just plug in, and in this case, again, I went over to my Arnold attributes, and well, this one here I didn't do my flip green. Might have had that set. I think I may have just forgotten to do that, or you know what? I'm thinking here, and like in this particular case, I could have just made an Arnold preset for myself where I just, set the to DirectX instead of the OpenGL output. But either way, you see how you can control that. You can just flip it. You can flip your red and green in Maya as well. Okay, so like I said, very, very simple for using Arnold. So now let's actually take a look at how we can work with this with something like Vray, which is going to do, which is actually going to need some type of conversion to this. So it's going to be a bit different. So what we'll do is the Substance Painter version first, because it's a little easier. So let's open up a scene here, and let's see. Well, we've got Vray for Painter. So we'll open it. You'll see it's going to use the same sample sphere scene here. So don't save. And here I'm just kind of getting the scene set up. Okay, here we go. All right, so also I have this set up. Let me open up Painter real quick, because I want to talk to you about these export configurations. Should be just a second here. I'm just waiting for Painter to kind of open up. Here we go. And let me just drag this over here to the monitor, and let's just open the sample sphere scene that we've been working with. Preview sphere. And just a second here, I'm waiting for this scene to open. A lot of waiting. Oh, okay, finally. All right, so like I said, this is our sample sphere scene that we're going to be working with. And so I'm just going to right-click and just take a look at my export textures. And underneath our configurations, we already have like a Vray setup here. So I just wanted to look at that. So here's our Vray setup. And so what it's doing is it's just using these converted maps. Now, these converted maps only work when you're using the metallic roughness workflow, because that's the only way we can convert these types of maps from metallic roughness. And you'll see what it's doing is it's going to export for me diffuse, reflection, gloss, and IOR, and then we have height, normal, and emissive if we need those. So you can see that here, our diffuse is converted here from this converted map. We have reflection, which is here. And then we have our IOR, which is actually this 1 over IOR, and that's converted from here as well. So these are going to kind of handle the outputs that we need. So in this particular case, you work inside of Painter just using metallic rough, and then you can just export. You just use the Vray preset, and you're ready to go. So now, if we jump over here into Maya, you can see what we have. So here, we're just using just the Vray material. So let's select this guy, and let's take a look at these settings. So I've got all my maps imported, and here you'll notice that we're going to set the color management the same. So this particular one is glossiness, so it's set to raw, and let's look at our color balance. Alpha is luminance. Reflection is set to sRGB because this is a color image. Diffuse, same thing, sRGB because it's a color image. It's representing color that's reflected back to our eye that we can see. Our sphere IOR, this is a data map, grayscale map, so we set it to raw, and alpha is luminance, and then of course our normal is set to raw. No need for alpha is luminance. So here we have our material, and it gets plugged in like this. So the diffuse is going to the diffuse. We set the amount up to 1. Now for the reflection, you want to make sure that you set the BRDF type to GGX. Because that's the same BRDF that we're using inside of Painter. It's going to give you a much more realistic result as well. So just make sure you set that to GGX. Your reflection color here is going to be placed into the reflection input, and then we set the amount all the way to 1, so we're basically just using 100% of that map. Then we have our reflection glossiness that's getting plugged into here. Then what we want to do is we want to, here, let's do this. Let me just create a node. And under Vray surface, where we have our Vray material, let's just make a Vray material real quick. So by default, you'll notice that this guy here, if we select him, there's an option here that has this lock Fresnel IOR to refraction IOR. Now in our case, we don't want to do that because we're going to drive this specifically with this Fresnel IOR map. So what we're going to do is we would uncheck this. And when you do that, that opens up this Fresnel IOR input for us. So here, if I go back to my Vray material, you can see that here we have that unchecked, and then the Fresnel IOR gets placed right into here. Then we can also make any kind of tweaks here to that GGX tail fall off if you want to, just for stylistic type stuff. In our case, we're not working with refraction in this particular option, so we don't need to worry about any of this type of stuff. Nothing here under reflection advanced that I need to change. Then here under your bump and normal mapping, you can see that I'm actually using here just an image that I'm plugging. This is just my normal map, and we set this here to normal map in tangent space, and then we plug this in. And then here in the Vray, so for the renderer, I'm just using Vray IPR here for my viewport, and you can see the result that we're getting, and it just pretty much almost 100% matches what we have here inside of Painter. Minus a little bit of the maybe the direction of the environment's a little rotated differently, but the result that we get is almost exact. I mean, it's never going to be perfect 100% one-to-one because here inside of Painter we're actually working with a shader that's set up for real-time rendering and so on. So here inside of Maya, what we're doing is we're looking at it using a ray traced physically based method. So it's it's going to be a little different, but for the most part, it's pretty much one-to-one, which is nice. And so you can see that the setup here through Vray, just exporting out of Painter, is really simple. You just use the Vray export, and then you can just plug the maps in. The biggest thing is that you just need to make sure that like I said, the reflection BRDF is set to GGX, and you unlock the Fresnel IOR to the refraction IOR. Now, this also opens up the ability for us if we did have some type of transparency and we did want to work with refraction. Now that those are unlocked underneath refraction, we can set a specific refraction amount for those transparent areas and so on. So here's how we set this up. Okay, so the next thing that I want to show is more in lines of how we could manually do some type of conversion to this here inside of Painter. And this could also be good too for like a teaching model or something. So let's do this. Let's open up a scene. And I've got a scene here. which is going to be my, let's see here, Vray. Hopefully, I think it's this guy here. Let's see what we have. So in this, what I'm going to do here in this scene is I'm going to use the substance plugin just like we did with Arnold. But we get this issue because the substance, like I said, if we're using something from, say, source, like we're doing here, we don't have the reflection. We don't have the IOR map. We don't have that. We have some of the maps, like we have diffuse and glossiness that we can use, but it's not going to help with what we're getting here. So here, let me just bring up my hypershade, and we'll let Maya kind of flip out a bit with all these panels opening and closing. Okay, I think it's done with its business. And then what I'm going to do now is to show you how to manually do some conversion to this. So to make this kind of easy, what I've done is, and like I said, you'll see this in the new rendering documentation that I put together. So now, for example, let's say I had like a brand new Maya scene. I could now come up to File, Import underneath my hypershade, and let's see, shader network. Okay, so here I just give, in the documentation we have a link to this file that's called substance_vray.ma, and here I'm just going to import this. And everything's just kind of mixed together. So here, let me reorg the, let's see, well, this guy, let's see, graph the materials. Nope, that's not it. Rearrange our graph. There we go. Okay, so what this does, when you import this into like a blank Maya scene, so there, let's expand this view a bit. This is going to give you these conversion nodes for you. So you can see I've got like a file input here with a note that says replace with the substance roughness, replace with base color, replace with metallic. So here's what we have, like this. So you can either replace these with textures that you have, or you could replace them with the actual substance outputs like I've done up here. So the idea here, and this is kind of what I want to go through, is how we're going to start to build up manually these conversions right here inside of Maya. So like I said, the first thing that we want to do here, let's just move these guys around. If we look at our V-Ray material, here we have this diffuse. So let's take a look at the diffuse texture to start. So here, let me expand this guy. Oops. Move this guy over. Okay, so the first thing we have here is going to be our color. And this is going to be our diffuse. So let me show you what we actually do in order to make this work. So what we want to do to create the diffuse. So in this particular case, what we want to have here for the diffuse is we're going to use our metallic map here to create this. So we have the metallic map, and like I said, the metallic map is going to be more like a utility to help us create or convert these other types of mats. So if we kind of look at the differences between what is base color and what is diffuse, well, in the metallic roughness workflow, you have base color, and it's going to represent it's going to specifically represent your metallic reflectance values is what you have there in your base color. For your diffuse map, you're going to you're just going to see inside there your diffuse reflected colors. So no reflectance values. They're just going to be the diffuse reflected values. So like, for instance, you know, the light hits the surface, it reflects back the colors that are reflected back to our eye. That's what that's going to represent. Now, like our base color map, like I was saying, it represents two pieces of data. I actually forgot to mention that. Like I said, we did cover base color represents the metallic reflectance value, and it also covers the diffuse reflected value as well. So that's what the base color albedo is. So reflectance value and diffuse reflected. And then diffuse is just diffuse reflected value. Both of those can be referred to as albedo. But base color is typically, you wouldn't say albedo because it's actually, well, there is some albedo value in there, but The other thing about it is that you have those metal reflectance values. So one thing here, I'm just looking, I just want to check over here at this question. So let's see here. Let me just read this question here. Is there a way to have a file input? Yes. Okay. So one of the questions here is there a way to have a file input for a substance? Yes, absolutely. You can do that. So that's a good point. So like let's say that up here we have a substance, and inside of Substance Designer, which I actually have open. So let me just bring that over here real quick so we can address that question. So we'll bring this guy into view, and here is the substance that I've just been kind of working on lately. Let's say that I have this substance here, and I want to be able to, let's say for my base color, I want to be able to replace this with an image inside of Maya. So all I have to do, if I hit the space bar, I can come over here to my input color. So you grab an input node, and then you will just make the connection like this. And then, of course, you can give it a usage in here if you wanted to. So here that you could set this usage to be base color, or you could leave it blank in this case. Not really super important. For the label field, you could just give it whatever you want. So this is your input here. Now, let me get this guy out of the way. We come back over here to, say, substance. If you select the substance node and you come over here to your substance parameters, underneath, well, in this particular case, this says basic parameters and advanced parameters. It's just the way the person who authored this substance grouped them. So if you had a custom substance, you could group it or you could not. But underneath your parameters, you're going to see just a texture input field, just like you would any other kind of texture input field. Maya, it would look something like you would see. Here, let me do this. We don't really have one in this particular substance, but let's just pretend normal intensity. It would say, like, you know, whatever you named it as the input field. You wouldn't have a slider. You would just have this little box here, like where you could just click to add a texture, and then you could just either middle mouse click and drag your texture onto it or whatever, and then that texture would get fed in through the substance. So it's pretty powerful, because maybe what you do is you have that substance or that image, maybe it's a normal map, you know, from something else that you baked. And then inside your substance, that normal map, you know, does things like converts curvature and AO and all this stuff that derives all these procedural type effects for your material. So you would have a substance material that can be completely generic and that can change based on the type of normal map you feed into it. So then you could see, you could use one substance on different materials, just feeding it, or different objects, feeding in a different normal, and have it, like, you know, recompute everything to fit the curvature of the new mesh and so on. So that's a way to kind of work through that. Okay, so yeah, like I was saying here for this piece, we were talking about base color and diffuse and all that kind of stuff. So like diffuse is just diffuse reflected color. So for example, if we're looking at a metal doesn't have a diffuse reflected color. So it needs to be black. So that's why if you look at a diffuse map for something that's a pure metal, it'll just be black, 0, 0, 0 for RGB black. Because, like I said, no diffuse reflected color. It does have a reflectance value, though. So, yeah, I think, yeah, using the old Maya, like I said, just make sure you go out to the website and download the latest version, because, yeah, the old version's super old, like 2012, and it's very buggy and everything. Like I was saying, you had that diffuse value, and it's going to be black. So we need to make that. And so to do that, it's actually not too difficult. We can take our base color, and then here you can see that I'm multiplying that. So I just use a multiply divide node. I'm multiplying that based on the invert of our metallic. So you take our metallic map, you invert it. So, you know, the metallic map being white is going to be what's metal, and black is going to be what's not. So we just do the invert so that the metal areas are now going to show as black. And we just multiply that over top of our base color, and that creates a diffuse map. So we can do that and then plug that right into our diffuse color. So that one was super easy. So next, we would have our reflection color. So again, you can see here, I've set the amount to 1, BRDF set to GGX, and now we need to do our reflection color. So let's take a look at how that is created. So here's our reflection color. Now here's the way I do this. So again, you'll notice that I'm going to be using our base color, and I'm going to be using our metallic, and I use a layered texture to do this. And let me pick this value here. I'm just checking something. Okay, seems to be okay. That was for my IOR. Okay, sorry about that. Just thinking outside, just thinking out loud. Okay, so now we have our base color, and as you recall, like I was saying, our base color is going to represent that diffuse reflected value, and then it's also going to hold within it those metal reflectance values. Now, if you thinking about the spec gloss workflow, those metallic metallic reflectance values are placed in the specular map. So those same values are just the same. They're just in a base color, you know. So it's the same data. It's just how we're storing it in different maps. So to create this, what we want to do is the same thing. We want to take our metallic map, which is like our mask between something that's metal and something that's not metal, and we want to just invert it. And then we're going to use a layered texture to stack this together to build up a new map type. So what we're going to do here in this case is we're going to set the first color value here to be white. So I set that to be full white. Now, the reason we do that is because if you look at metals, their reflection color is going to be tinted. So they're always going to have some type of tint to them. And they're going to be a high value too. Like we usually say, like if you look at metals, they're going to represent at least 60 to 70% reflectance values and higher. And they're typically going to have some type of tint to them. Now, if you have a dielectric material, though, something that's non-metal, its reflection color is not going to be tinted, so it just needs to be white, so pure white. So that's why here we place this here as pure white, and then here we've got our base color placed into here, and you'll notice that here for the alpha, so this is our white color, and in the alpha is where I have my inverted metallic map, like this. And so what that produces for us, and it's kind of hard to see right here, so let me show you this. Let me do this for you guys. Let's bring Designer back for just a moment. And let me open this guy. Sometimes the thumbnails work, sometimes they don't. Let's see, where do I have this guy? I'm looking for the substance that we're using inside of Maya. So I think it's in here, in my integrations, substances. Here he is. All right, let's just bring him into here real quick. I say that, now we got to wait for everybody to load. All right, here we go. Come on, come on. I'm sorry. System's going to a crawl here. Almost there. But what I'm going to show you here is like, I'm going to use our conversion nodes so you can actually see what the map is. So this is, you know, this here you can see I've got just, you know, base color, rough metal and all that kind of stuff. So let's just come over here to my material filters, PBR utilities, and inside here we have the base color roughness converter. So here's another thing you can do, like if you're creating custom substances, instead of doing this conversion like inside of Maya, you could just do it here. So like you could just, you know, author and at the end output actual diffuse spec and gloss. But here what we're going to do is I select this node. Here, let me hit 3 on the keyboard to put this in material mode, and just so I can make one connection really quick. And you can see that it just hooks everything up for me. And I'm going to switch my target here to Vray, and then this is going to give me the diffuse and my reflection. So here you can see what's happening here with this reflection that we're trying to create. Now in this particular case, you can see with my metallic, the thing is pure white. So doesn't really give us too great of an example. Sorry guys, let me just open another one. This will be much better. With it being full, metal being full white like that, it's kind of hard to really see, you know, what the conversion process is doing. Okay, so here's our site. This is a different substance, and I think it has some variation in the metallic map. So let's double check it and see. Well, yeah, it's almost black and white, but it's good. It'll work for us. All right, so let's do this. Let's use this guy with our converter map. All right, and let's bring it back. Okay, so let's look at this guy now underneath Vray. So if we look at our reflection now, you can see here's exactly what it's doing. So if we look at our base color, so here's our base color. This is what we have. And then remember, I'm using that layered texture, and we're layering in white. So we have white at the top, and then right below it's our base color, and we're using our metallic map. So here's the metallic, and you can see here, we're going to use this guy as a mask. So we just invert it so we can use the white is where we're going to use the alpha part. And then if we look at the reflection, you can see that in the reflection, everywhere where we have a something that represents like the non-metals, okay? So if you look at it again, let's look at our metallic map. The non-metal values are black. So everywhere you look at the non-metal values, they're going to be pure white. So like I said, because the dielectrics, they don't have a tint to their specular value. So that hopefully gives it more of a visual of what we're doing here. So that's where we have pure white, we have our base color underneath of it, and then we're just doing a mask here with our alpha, an inverted version of our alpha, and then that's what we have. So that's how we create a reflection map that we can use. So the next one is going to be our IOR value, and this one is pretty similar to the reflection. So as you'll notice, we're going to use our metallic again. We just invert it so that we can target what, we want to put white in our mask where the dielectric is. So that's just why we do a reverse. Now, we have a little bit of a different setup here, though. So here, let me jump back over here to Designer so we can, that's Painter. Let's jump back over to Designer so we can get a little visual reference of what's happening here. Now you'll notice something a little different. So here, this is the 1/IOR map. So here you'll notice that all of the places where we have something where the metallic is saying, let's look at the metallic map, come on, is pure white. We're setting this IOR value here, and let's sample the actual value so you can see them. So you can see here the value is 0. So that's going to be black. Now, what we want to set up is the IOR value for the non-metal. So that's what we're doing here with this map. So black, we're not worrying about the IOR for the metallic because we actually are working with that in our reflection. But we now need to set the IOR for the non-metal value. So you'll notice here that this guy has a specific value in here. Let me zoom in. And we'll look at this, and you can see it's 0.666667. And so what that actually equates to is basically a default. Here, let's go back over here to Vray. And let me create... Let's do this. Let's create a node just so we can see it by default. Vray, surface, material. Here we go. Go back to this guy, and you'll see it right in here. Let me unlock it so it shows up. Now, see the Fresnel IOR? 1.6 is what it defaults to. So that's going to handle like glass IOR. Well, no, more like just it's kind of close to the range. Like I think in Designer, in our MDL graphs, we use 1.5. So it's pretty close to just using like it's basically like just setting up a common IOR for, I'll say an IOR for common dielectrics, the different ones like ground. Because you'll notice that the thing with dielectrics is that their IORs don't shift dramatically. I mean, if you look at a broad range in there are exceptions, like things like gemstones and other things, they're going to have, different properties. And here I'm not talking about things that are translucent or refractive either. We're just talking about like things like, wood, stone, rock, that kind of stuff. Maybe some types of fabrics, stuff like that. And they can vary, of course, but the differences is not dramatic. It's pretty small. And so a lot of times you can get away with just using the same value for a wide range of common dielectric type things. And so that's kind of what we're doing here. So we have this refraction IOR value. And so what I do, since that's precisely what we're going to use here in this layered texture file, we just set this value. So you'll notice if I look at the actual color, so we'll click the color picker. This is why for the value I'm setting 0.667, which is going to equate to that 1.6 IOR. So we set that in, and then we set black. Again, just a pure black color. Now for that IOR value, you'll notice again we have our alpha, and that alpha is our reversed metallic map. So that is the exact same as building up, if I jump back over to Designer real quick, the map that we have here. So if we look here in our view, if I just mouse over, you can see again our value, 0.667 basically, and then black in this area. So what we're talking about is the IOR, the 1 over IOR for the non-metal areas. And that takes care of the IOR map. And then here we obviously just use the normal map just as we did before. So this kind of shows you kind of a workflow for how you can convert base color, metallic roughness to the specific map types that you're going to need for Vray. So, and with that I mean like we're going to create that 1 over IOR and those kind of things. Oh, I'm sorry, one other thing that I didn't mention. So you'll notice here that I have this roughness map. If you have roughness, I'm just using the invert. I just reverse it. So it's just invert. Gloss is always just the invert of a roughness. Now, if you were using a substance, and I may have done that up here, instead of, let me check. Metallic, base color. Oh, nope, I did it here too. So in this substance, you can see that, like I said, they all ship with, instead of enabling roughness, I could have just enabled the gloss and not even had to worry about the reverse node. It doesn't matter. I just did it here, I guess, just so I could discuss that it's the invert and that's how it works. So, the key is, and as you can see in the end, just doing these type of conversions, it's not really difficult. And honestly, I kind of feel like that might be a good kind of lesson if you guys wanted to, if you're looking like when you're teaching PBR and things like that, it might be kind of a good kind of exercise to go through, like give someone those base metal outputs and then say, okay, now I want you to convert this. Because in that conversion process, you can see how you have to know what the data is in the maps and what it represents. And if you know what the data in the maps is, and you know what the data represents, then you can always convert them to fit any type of renderer. And that's basically all we do with all of our outputs. When we do, we just, we know what the data is, so we can just convert it. Because in the end, we're still talking about physically based data, and it all represents the same thing. And that, again, that's the beauty and what I love so much about PBR is that you do have this underlying consistent theory that's based on, scientific measurements. So with that, and again, you don't have to be a scientist to know how to do it. I mean, you just know what these represent, and then once you are armed with that knowledge, you can do whatever you want with the data. You can convert it any way that you need to, which is really pretty powerful, I think. Again, like I was saying, that might be a good exercise you guys could think about, for your students, because, when they work through that, they're going to have to know, okay, I'm creating diffuse. How do I create diffuse? What does diffuse entail? Oh, it entails things, different types of data. Oh, a metal doesn't have an actual diffuse reflected value and those kind of things. And once you kind of know, like I said, you get that stuff and you know it, it really, really helps you in your entire understanding of physically based material rendering systems. So like I said, that's one of the things, or the main thing I wanted to cover in this webinar, and we're just right at an hour, which was good timing. So I hope that this was actually pretty helpful this time. Like I said, we were looking at two of the most kind of the biggest renders that we get. So again, if you guys are wondering what kind of stuff we get asked about in like VFX studios that we've been visiting, also we have ArcViz and design teams now within Algorithmic who are focused specifically on those markets. Design market's very, very huge. Of course, and you guys can notice, you can see both Unity and UE4 are really trying to push into those markets as well. So like when it comes to, like, let's just say design, V-Ray becomes basically the #1 choice that we've seen, followed by right after that is the Corona renderer, and then right after that, I believe it's a UE4. So those are kind of like the top 3 type renderers that that we find ourselves constantly talking to in various webinars with design firms or in studio meetings. If we go to VFX, right now it's Arnold. So that's like the main thing that we see is Arnold, and then V-Ray use. So both Arnold and V-Ray. So that's why I really wanted to cover these guys here. I kind of left out Corona in this case because well, there's a Cinema 4D renderer for Corona that's in beta, and then the Corona renderer is really just in 3ds Max, and I think they have like a standalone though. I'm not really an expert with Corona, but so I didn't really want to jump into that too well. So yeah, we'll conclude the webinar for this time. And if you guys have any feedback or any questions, please just be sure to just email those to myself and Charles. Also, if you guys have any ideas of some of the things that you want to see in future webinars, please just drop me a line and let me know. I think what I would like to do in the next webinar is kind of get back more and focus into doing some more material type stuff inside of Designer. Because I think we've been focusing a lot on Painter lately. So thanks again, everybody. I really appreciate your time. And Charles will be sending out the recap email. And again, this is recorded, so you'll have that as well. So take care, everybody, and we'll see you on the next stream.